Welcome everyone to my Advanced Computer Network term paper presentations. We will discuss artificial intelligence for software-defined network, or AI for SDN, a topic that is relevant for the completeness of 5G network technology and for the future development in 6G. We first need to understand what SDN is. SDN can be formally defined as follows. Control plane and data plane are decoupled in SDN, which means that the logical decision of the router is independent from the forwarding protocol in low-level layers. Instead of the source-destination pair, like normal forwarding rules in most routers, SDN forwarding decision at a certain router will be a sequence of nodes or routers that packets must go through. The control logic of SDN, also known as Network Operating System (NOS), will abstract the network view. SDN must provide programmable property for the network application running on top of NOS. The development of SDN allows corporations to improve their network system to transmit over a wide area. We first need to know how corporations dealt with long-range network before SDN was introduced. Companies use multiple protocol label switching, create a fixed dedicated path from one branch to another branch of the multi-region corporation for communication. This implementation has some drawbacks, such as high cost and difficulty in configuring and maintaining the whole network. Due to high cost, redundancy is usually not implemented, which results in higher chance of network failure. SDN can connect corporate region branches to SD1, routing their network through many routers with consistent quality of service, preventing a single point of failure and reducing the cost needed for maintenance. Vendor providing network service can ensure a certain level of quality of service and create virtual dedicated routes for more than one customer. The development of 5G network is a catalyst for the development of SDN. With the special properties of SDN, allow network service providers to virtually separate the network into slices that cater to different purposes. Each slice logically acts as a group of connected networking devices. With the development of parallel computing devices such as CPU or TPU, the time taken for AI training is shortened, helping developer and cloud computing services to leveraging AI in network automation process. The example image on the right side shows the collaboration between Amdocs and Google Cloud for optimizing 5G network with AIs. We provide a prominent research as an example in using AI for routing optimizations. The example model named Critical Flow Rerouting Reinforcement Learning, CFR-RL. The PR value shows the performance ratio of the load balancing algorithm with the most optimal utilization. In other words, the algorithm with the PR value closer to 1 has the higher utilization that's closer to the theoretical optimal utilization. The paper showed that CFRRL model has the near optimal performance by rerouting only 10 to 21.3% of the total traffic. Another example of using AI in SDN is for network security. A paper from the University of Bridgeport suggests that we can leveraging transformer architecture from the two model, FED former and patch TST model to detect DDoS attack. The result from the experiment suggests that the patch TST model has a better performance in detecting DDoS attack. Despite having many benefits using AI for SDN, there are some drawbacks we need to consider. First is the energy consumed. For the relative comparison for the energy consumed for all currently common NVIDIA GPUs, we can see that T4 and A100 GPUs consume approximately 400 watt on average, while Blackwell GPUs consume around 1200 watt on average, which is comparable to a rice cooker, ranging to 400 watt to 1000 watt. Second is computational overhead. To perform inference on the complex model like transformer, the process time is significant in relation to the end-to-end packet transmission delay. To compensate for that, we need to invest in more expensive GPU, which is costly and consume more energy. Finally, performing drift occurs when model perform the task in the dynamic environment where the distribution of the environment inputs are different from the distribution of the training data. Fortunately, the reinforcement learning model can be trained in parallel in the simulation environment and replacing the old model when it cannot adapt to the drift events. AI for SDN is for support by 6G network technology. Since it allows cooperating AI in every layer, AI can also be used for routing energy control to put the routers to sleep when it is not in use. The development of agentic AI allow for networking automation to reduce manual work by networking engineer. In conclusion, the development of AI and the support of SDN will allow improvement in routing and networking security, but there are some drawbacks to be considered. The development of 6G technology and agentic AI create more room for AI in SDN development in the futures.